Okay, so we are trying to solve a question which came in 2023 JEE Main. So this question is asking us to solve this differential equation. So we have to find the value of y in terms of x. So if you look at this, first of all, then you see something like a trigonometric function here, and then some algebraic one as well. So the very first thing which we do in such cases is that we try to write this as dy by dx format. If I write it in dy by dx format, then what I get here is y sine x minus y, and then I'll have to divide it by cos x here, cos x. So this will become dy by dx, and then this will become y, and then if I divide separately again sine x by cos x, and then if I multiply y with y, so this will become y square upon cos x. Now in the next step, I could write it as dy by dx equals to y tan x minus y square sec x. Now here again, I don't see this of any form like a linear type or even homogeneous or variable separable. So what I do is again, I'll go one step further and write it as dy by dx minus y tan x. And this will become minus y square sec x. So this is called Bernoulli's equation because here you have got something in terms of y square, right? What you do is you divide it by minus y square to the both sides, or rather bring minus 1 by minus y square this side. So this will become minus 1 by y square. This will become dy by dx. And then this will become minus y tan x. And then there is a minus y square again here. So now this will become sec x. Now in this next step, what we will have here is minus 1 by y square, and this will be dy by dx. This will become plus 1 by y tan x, and this will be sec x. Now if you substitute 1 by y as t, so let's say let 1 by y equals to t. So what you will see that this will convert into linear differential equation. So when you differentiate both sides with respect to x, what will happen is this will become d of 1 by y upon dx, and this will become dt by dx. And you could write this as this d of 1 by y upon dy. So you'll have to apply chain rule. So dy by dx, and then this will be dt by dx. And then this will become minus 1 by y square actually. And this will become dy by dx. And this will become dt by dx. Now you can write these values over here. So this thing, entire thing will become dt by dx. Now this will become 1 by y could be written as plus t tan x. And then this will be sec x. Now this is looking like the linear form because in the linear differential equation, what we have is dy by dx plus p times y equals to q. And here it is dt by dx, and this is your basically function which you're looking for. This is p, and this is your q. So our integrating factor will be e raised to the power basically tan x dx, and this will be actually nothing but e raised to the power log sec x, and then this could become sec x itself. So you can again solve this linear differential equation like this. You could write it as here what you have is not y, but rather this time you have got t, right? So you could write it t into integrating factor, which is t into sec x, and then you'll have to multiply this sec x this side also. So this will become sec x into sec x, and then there'll be a dx. Now you'll have to integrate it. This is what is the final thing. So this is generally y into integrating factor will be equal to q into integrating factor and into dx, and this will be integrated, right? This is what happens. So this is what we have written here. So this will become t into sec x, and this will become sec square x dx. Sec square x is nothing but tan x, and then you can add one constant of integration. Now you can substitute the value of t, which is nothing but 1 by y into sec x, and that is actually equal to tan x plus c, and then you can get sec x equals to y times tan x plus c. And this is what will be your answer. So this is one way of doing it. Could we have done it in any other way? So actually, there was another way of doing it as well. So we'll look at that too. So what will be the other way to do it? So I'll just try to do it side by side over here. So now look at this again, cos x dy. And then I will just multiply this and then write it as y times sin x dx. And this will be minus y square dx. What if I bring in this to the other side, cos x dy, and then I'll bring in y sin x dx, and this will become minus y square dx. Now, if I divide this by minus y square, this side, cos x dy minus y sin x dx, and then divided by minus y square, this will become dx. Now, again, just because of minus sign, I'll rearrange it, and this will become y sin x dx minus cos x dy upon y square dx. So if I had looked at very carefully, right, first instance, we could think that this has become something like this, d of um, cos x upon y, right? This is what we will think. But when you look at here, this is fine, this y square is fine. But if I differentiate this numerator, then I should get a minus sin x here, which I didn't get. And to the other side, if I go further, then I should get a minus sign, which again, which I will be having. So this is fine, but there is an additional negative sign coming, and because of which this is not going to work. So d cos x upon y, if you want to actually evaluate, what will this be? This denominator y square, y into d of cos x upon dx, which is minus sin x, and then minus cos x into dy. But here there is a plus sign. So this is not the one, right? So what should we do actually, right? So again, if you look very carefully, what you can do is that if you divide both sides by cos square x, what will happen? This will become sin x upon cos square x dx, and minus cos x upon cos square x dy, and this will be upon y square equals to dx. Now this will become y, and one of the cos I'll take, and this will become tan x into sec x dx, and this will become cos, one of the cos x will go, this will become sec x dy upon y square, and that is going to be equal to dx. Oh, then there is another, of course, both the sides you have divided, so this is cos square x. So then you should write sec square x and then dx. So now what I've got here. So if you look at now this one, this is definitely something like this. You can say this is now sec x upon y. So if I differentiate this, then definitely I will get a y square in the denominator. Then I'll get y, and then differentiation of sec x will be sec x into tan x, and this is basically dx, and then minus sec x into dy. So this is the differential of this, and this is gonna be sec square x dx. Now, if you integrate both sides, then you will get sec x upon y, and this will be tan x plus c. And then what you get is again sec x equals to y times tan x plus c. So this is another method to do it. And then, of course, when you look at the option, you get an idea, because what you'll see in the option is something related to sec x and tan x. So once you are stuck here, and you're not able to see this is working, then think about dividing it by cos square x, and then it'll start working for you. All right. So that's all I wanted to discuss in this question. Thank you for watching.